Hi, this video is about IP subnetting. So why we do the IP subnetting? IP subnet is used to divide a large network in a logical group. It helps to preserve the address space and security. It controls the network traffic and improve the performance drastically by reducing the collision. So when one host sends data to the other host and if both are on the same subnet, then router recognize it and traffic stay on the same subnet. But if host is not on the same subnet, then router send traffic to the different subnet. This slide I'm going to, before we do IP subnetting, I try to cover the binary to decimal. So let's say if you have 1 byte, that is equal to 8 bits, and if all the bits are set to 1, so to convert to the binary to decimal, basically you just add the exponential value up to 2. So the first bit here, it will be 2 raised to 0, second bit will be 2 raised to 1, that is 2, third bit will be 2 raised to 2, that is equal to 4, and so on. So that will be, if you make the summation of all this, it will be come out to be 255. So if all the bits are set to 1, then its decimal value will be 255. In the second example, let's say we have only 2 bits are set, first and last one. So in that case, your decimal value will be 128 plus last bit 1, that is equal to 129. This slide covers the binary representation of the IP address. So let's say your IP address is given 172.23.120.3. To convert to it decimal, you just break it down, and here I can see that 172 can be break down into 128 plus 32 plus 8 plus 4, and then you put the 1. So the binary pattern will be this one. For the 172, it is 101011000, and same thing you do for the 23 here. 16 plus 4, 20 plus 2 plus 123. So here the binary pattern will be 0001011, and you do the same thing for the remaining 2 decimal numbers, and the complete binary address will be this much. This slide covered the type of network. So basically there are like 3 type major network, type A, B and C, and the valid network on the type A is 1.0.0 to 126.0.0, and the first 8 bits are for the network, and remaining 24 for the host. Here in the type B network, the valid networks are 128.1 to 191.254, and 16 bits are used for the network and 16 bit for the host, and the octet will be 128 to 191, and possible network can be 2 raised to 14 minus 2, and here possible host can be 2 raised to 16 minus 2. In the class C network, you have like first 3 bytes, that is first 24 bits, they are used for the network, and last 8 bits used for the host, and the valid network is 192.0.1.0 to 223.255.254.0. That will be the first valid network. The total number of network can be 2 raised to 14 minus 2, and total number of hosts can be 2 raised to 8 minus 2. Before we start to go over IP subnetting, I want to cover one more thing, AND table. So if you let's say in the AND gate, if you have 2 input 0 and 0, then output will be 0. If you have 1 0 1, then it will be 0 again. 1 to 0 is equal to 0. Both input has to be 1 to make output 1 here. So just remember this AND table that's going to use on the IP subnetting. This is a class B example. So let's say you are given the IP address of 172.23.115.3, and your mask is 255.248.0. So here the question, what will be your network address? So if I convert, the first thing I put in the binary presentation form here, then I put the mask here, in the binary form, and this is class B. This 16-bit are used for the host, but when you do the subnetting, you borrow some of the bits for the network portion to create the subnets. So here, based on this mask, I can say that 248, that is summation of this 5-digit in decimal form. So here the 5 bits are used for the subnet, and the remaining 11, right? So the remaining 11 bits are used for the host portion, and here the number of possible network can be 2 raised to 5 minus 2, and possible host can be 2 raised to 11 minus 2, that is 2046. That many networks can be you can create, and that many hosts per one subnet. And when you do the AND operation on bit by bit, that will be your network address. So here in this case, if I perform for this bit and AND operation of this bit, that is 1 and 1, that is output will be 1, and I do the same thing for all the bits. Here in this case again 1 and 1, the last bit is 1 and 0, so output will be 0. So the network address will be here 172.23.112.0. Now let's take a look at the class C example here. In this case, let's say I am given the IP address 195.11.124.67 and my mask is 224. The last byte, from the last byte 224, I can see that the 3 bits are used for the subnetting here, and remaining 5 bits are used for the host. And when I do again the AND operation, my network address come out to be 195.11.124.60. It's equal to 30 possible hosts per subnet. Okay. Let's say you are working on some company, and then your company is assigned the class C address. That means the first 24 bits are used for the network, and your last 8 bits. Now you have 10 departments here: accounting, engineering, HR, etc. And you have 13 employees per department. So based on this scenario, how many bits will be used for the subnetting? So here for class C, we know that 8 bits used for the host, and since I have 10 department, I need to have at least 4 bits for the subnetting. So 2 raised to 4 minus 2, so that give me the 14 subnet, one subnet per department, and 4 will be unused, that can be used in the future. And my requirement is 30 employee per department, so in that case I have 4 host bit, and that is 2 raised to 4 minus 2 is equal to 14. So I can use assign the all the 13 employee, and I still have one more address space left for the future employee expansion. So hopefully this will help on the IP subnetting. Okay, bye.